we're going to be doing addition rules for probability. There are actually 2 or 3. I can't remember off the top of my head. I think there's only 2 for addition, 3 for multiplication. So addition rules for probability. There are actually more than just the 2 to 3 rules that we have, but some of those I'm including as bonus, and some of those I'm just treating as part of one of the rules already. So let's get started. This can be a complicated subject. So there's 2 rules for this one to start with. I think there's another one later. Okay, so 2 events are mutually exclusive events if they cannot occur at the same time. In other words, they have no outcomes in common. All right, so the probability of having probability depends on, and the addition will depend on whether or not they're mutually exclusive. So, for example, if we talk about boys and girls, right? If you're a boy, you're not a girl, and if you're a girl, you're not a boy. So those are mutually exclusive probabilities. All right, so they're mutually exclusive events. So you have to look at, is something mutually exclusive or not? If it is mutually exclusive, then you want to find the probability of A or B. Now, this is not always, but I would say 9 times out of 10, when you see the word or, you're using an addition rule. This is important, okay? If you see the word or, you're using an addition rule. So when 2 events A and B are mutually exclusive, the probability that A or B will occur is the probability of A plus the probability of B. Yesterday we learned how to find basic probabilities. Today we're adding them together to create another probability. Now, if they're not mutually exclusive, you have to take the probability of A, add the probability of B, and then subtract the probability of both of them happening. I promise we'll get some examples on how that works. It's really not as hard as it sounds. So let's go to an example. Let's start off right away. Okay, so the first example question is how to tell if something's mutually exclusive or not. All right, so you have to decide, is it mutually exclusive? So if we roll a die, and we want to say getting an even number and getting a number less than 3. Well, let's look at what our sample space is. An even number is 2, 4, and 6. A number less than 3 is 1 and 2. So are these sample spaces mutually exclusive? Well, you'll notice the number 2 is in both of them. Since the number 2 is in both of them, the answer is no. We are not mutually exclusive because 2 occurs in both sets. All right, so the first part of your homework and the first part of your assignment, and the first practice problem is just deciding. Now, yes, I put 4 of them on there because I want you to know, are they mutually exclusive or not? So, go ahead, pause the video, do the problem, it shouldn't take you very long, and check your answers. Here's your answers, and they explain why. Okay, practice problem number 2. At a community swimming pool, there are 2 managers, 8 lifeguards, 3 concession stand clerks, and 2 maintenance people. If a person is selected at random, find the probability that the person is either a lifeguard or a manager. So in this example, we know that they're mutually exclusive because there's nothing that says some lifeguards are also managers. So let's look at how many we have total. We have 15 people total. If we have 15 people total, and we want to find the probability that somebody is a lifeguard or a manager, that means we're going to add the probabilities together. So my lifeguards, I have 8 lifeguards. So that's the lifeguards, and then I also need to find managers. I have 2 managers. And so since we're trying to find the probability of 1 or 2 of these events happening, we add them together, and I get 10 out of 15. If I reduce that, I end up with 2/3. That is my probability of if I were to pick a person at random, that I would either end up with a lifeguard or a manager. Okay, here's your practice problem. Pause the video, do the problem. Check your answer. Okay, example 3. I need to move it because I can't see it. All right, there we go. So we want to know what is the probability of, this is the other one we talk about when they're not mutually exclusive. So it says the probability that a student owns a car is 0.65, and the probability that a student owns a computer is 0.82. If the probability that a student owns both is 0.55, what is the probability that a given student owns neither a car nor a computer? Now, I will say this is one of the harder problems because it doesn't say either or. It says neither nor. Now, when we talked before in the last lesson, we talked about the complement of an event is 1 minus the probability of it happening. So we're actually going to find the probability of A or B, and then we're going to go 1 minus. Now, before we even do this, we need to talk about the fact that these are not mutually exclusive. Okay, there are students that own both computers and cars, so we need to use that rule where it's the probability of A plus the probability of B minus the probability of A and B. So let's go ahead and find the probability of A or B, and then we'll subtract it from 1 to get the probability that it doesn't happen. So the probability of A is 0.65, and the probability of B is 0.82, and the probability of both is 0.55. So we're going to figure this out first. The probability of owning a car or a computer is 0.92. So if I add these up and subtract 0.55, it's 0.92. But I don't want to know that. I want to know what's the probability that I don't have either one. So that's 1 minus 0.92, which is 0.08. So this was more of a challenging problem. I think your practice problem is actually easier than this. But this takes into account more than one probability rule. You're going to have problems like this, so be aware of that. Okay, here's your practice problem. Here's your solution.